Hi guys, welcome back. We're going to continue talking about polynomials, and we are going to add and subtract polynomials today. Okay, so let's just remind ourselves 2x plus 3x is 5x, right? We've done that for a long time now. Okay, now 2x squareds plus 3x squareds, that would mean there's a total of 5x squareds. Okay, notice here, because I'm adding, okay, we don't have exponent rules for when we're adding bases and subtracting bases, so we just add their coefficients or subtract their coefficients, okay? And we keep the x squared the same all the way through when we're adding and subtracting, okay? So 2x cubed plus 3x cubed is 5x cubed, okay? And what about 2x cubed plus 3x squared? We cannot combine those because we're adding and they are not the same exponent, okay? So this just stays the same. I cannot combine them. They're not like terms, okay? Just like we can't combine x's with y's, we can't combine x cubes with x squareds. They just stay. Can't combine them, okay? You can only combine like terms, so stick that in your brain and keep it there. So if I'm looking at this problem here, I see that I have 15m cubed plus 6m squared plus another 2m cubed. So I would combine the m cubes. This would be 17m cubed. Whoops, sorry guys. Plus 6m squared. Okay. Again, we should be writing our answers in standard form, which just means they're in descending exponent order, because remember, this monomial is a degree 3 and this monomial is a degree 2. Okay. Feel free to go back and watch that video if you need to on standard form. Okay, let's look at another one. So here I'm seeing 3x squared minus 7x squared, and we have two constants, 5 and 12. Well, 3x squared minus 7x squared is negative 4x squared, so make sure we're taking the sign in front of the number. And then 5 plus 12 is 17. Again, that's in standard form. We have our x variables, and then we have our constants. Okay. Ooh, decimals, our favorite thing. Okay. We're going to do the exact same thing. These are all to the fifth, but be careful. This one, oops, sorry, wrong color, is an x to the fifth, while the rest are a y to the fifth. So 0.9 minus 0.4 would be 0.5, and there's an invisible 1 here, so that's going to be 1.5 y to the fifth, okay, plus 0.5 x to the fifth. Again, once we have two variables, standard form kind of goes out the window. It doesn't really matter. Typically, we'll put the variables in alphabetical order, so usually we would put it like this, but it really doesn't matter in this case. Okay, so standard form is when we have one variable, so if you have more than one, we just kind of don't worry about it. Okay, now sometimes what they'll do is they'll give you these two polynomials and they'll be like, add them, and you're like, okay, cool, but they're in these parentheses, so as long as there's nothing right outside the parentheses, like a number or a negative sign, you can just go ahead and add them together. So 2x squared plus x squared is 3x squared. I kind of like to look and see what exponent is the highest, so I see the x squareds are the highest, so I add those together first, so it's easier to write in standard form. And then I'm just like, oh, let's see if there's any x's. So we have negative x plus 3x, so that's going to be plus 2x. And then this minus 1 just has to come along for the ride because there's nothing to combine it with, but we can't just like ditch it, right? We can't be like, oh, no, we don't need it anymore. It just comes along for the ride. Okay? All right. Why don't you go ahead and try this one? Okay. Well, we have negative 2ab plus 2ab, right? That's 0, okay? So even though there's two variables, the ab's go with the ab's, okay? And then we just have a b plus a, and since those can't combine, we just write b plus a, or a plus b would be the same, okay? All right. Go ahead and try this one on your own. 4b to the fifth plus 3b to the fifth minus 7b to the fifth. So that would be 7b to the fifth minus 7b to the fifth, which is just 0. So these all cancel out together. And then I have 8b plus 6b plus b. So 8 plus 6 is 14, plus 1, because remember there's always an invisible 1, is 15b. Okay. Now minusing, we do the same thing, but remember we basically distribute this in. So this would be 2x squared plus 6 minus 4x squared. Okay, so 2x squared minus 4x squared, well that would be negative 2x squared plus 6. And we distribute the negative into each term, not into each piece. So like it's not going to be negative x squared because the term is 4x squared. So that's why it's just minus 4x squared. Again, this one, I want to see you write the distribution out and say, okay, this is a to the fourth minus 2a minus 3a to the fourth plus 3a minus 1, okay? What I see students do is they minus the first part and then they keep everything else the same over here. We don't want to do that. So definitely write this step out right here so that way you know that what you're adding and subtracting, okay? That will save you a whole bunch of heartache. So we have a to the fourth minus 3a to the fourth, which would be negative 2a to the fourth. I have no a cubes, I have no a squareds, so I'm going to move on to a's. Negative 2a plus 3a would be plus a, and then this minus 1 comes along for the ride. Okay. Go ahead and try this one. Again, let's make sure we're distributing this negative here. So we have 3x to the fourth minus 2x plus 8 minus x squared plus 4. So I have an x to the fourth, so nobody to combine with, so he's just going to come along down. We have no x to the third, so no big deal there. X squared, none to combine with, and then we have some x's, so minus 2x, and then we have our constants. So 8 plus 4 is 12. And again, our answer should be in standard form. That's why I wrote x to the fourth, then the squareds, then the x's, and the constants. And make sure you're combining like terms as you go along. Okay, so this would be our final answer right here. I believe that's our last problem. I hope you have a wonderful day, and we'll talk to you later. Bye.